Hello everyone, hope you all are doing well. So welcome to the day 2 of the challenge that we have been solving. So if you are new to this playlist or channel, so there is a new crash course introduced by Leetcode. You can see here Leetcode interview crash course. So what we are doing is we are solving each and every question in this one. So it's a paid course, but we are solving it ourselves. Also, I'll be adding some more problems here because it's a list of 60-70 problems, but obviously solving 60-70 problems is not going to make us a good problem solver. However, we will be briefly touching each and every aspect. So apart from these questions, we'll be solving much more questions than this. The main motive right now is that we keep on touching each and every topic, right? Also, I have picked up the questions randomly, because if I tell you that today we'll be solving a problem related to bit manipulation, so in that case what will happen, your mind will always go to a solution related to bit manipulation. So we will pick up a question, and then we will see how to approach it, and based on that we will devise the algorithm. Based on that we will see that to which category does it belong, right? So this is the approach that we will be following throughout this series, right? It's going to be a long series, probably one month, 1 month or 1.5 months. So today I'm targeting a couple of problems, similar problems related to linked list. Now linked list is the data structure that we will be covering first, because I thought array and string is something very common. So let's cover something that is uh, not discussed much. So that's the reason I've started with the traditional problems along with the proofs, right? Like for example, if you want to delete a node from the linked list, from the middle, then why does the algorithm, that is the standard algorithm, work? That also we need to understand, right? Just mugging up the algorithm will not work. Similarly, when we want to find the cycle in a linked list, right, whether there is a loop or not, then why mathematically we will prove that why that algorithm works. So we'll be following this approach on our channel, right? So today is day 2. I have again picked up a traditional problem, reversing a linked list. Why I have picked it up? Because I have seen folks writing very complex code for this. So today we'll be understanding that what how should we start thinking for this type of problem, right? And once you know how to reverse it, there are again more sub problems that are related to it, right? So again, problem statement is very simple. So I have a linked list, right? Suppose this is 1, this is 2, this is 3, this is 4, this is 5, and so on. So I need to reverse it so that the new list becomes something like this. So right now 4 is pointing to 5, so 5 points to 4, points to 3, points to 1, something like this, right? Or for simplicity what I can do, let's remove it, or and I can make it like this. So there is 1, 2, 3, 4, 5. Now this points to this points to this point, right? And so on, right? So now comes the question, how should we approach it, right? So consider it in the form of two things, right? So this is a list that we have, let's call it L1, right? And this is the list that we need to convert to, let's call it L2, right? Now while converting it, obviously there are other methods that what you can do, you can modify the nodes and all that, but we'll be discussing the approach which is the optimized one. Since it's an easy level problem, I won't go into too much of details into other solutions, right? We'll be discussing the best solution itself, right? Now here, consider this. So this is L1, you want L2, right? So consider a temporary list, let's call it TL, right? Let's call it TL. So what we need to do, this is a temporary list, this is an empty list, right? And this is my L1, right? So what I will be doing, I will be taking help of an empty list to convert my L1 into L2, right? To convert my L1 into L2. Now what will be the steps, right? So this is an empty list, my L1 is 1, 2, 3, 4, and 5, right? What I can do, I can pick up one element, right? I can pick up one element. So right now elements are like this. I can pick up one element and make this element point to this empty list. So it will become like, so this is just the representation of an empty list. So this will become like this, right? This is step 1. So now this becomes this, and L1 becomes 2, 3, 4, and 5, right? What will be step 2? I can do it like this, right? And this becomes 3, 4, and 5. Similarly, at step 3, what I can do, I can append 3 at the back like this. So this list becomes 4 and 5. So see this, I'm modifying L1, I'm adding the element at the front, at the back of the new list that I have, a temporary list. And finally, what will happen? It will become something like this: 1, 2, 3, 4, 5, and this will be an empty list. Let's call it null. So actually, this also is null only. Just for representation, I made it a box, right? So this is what we will be doing, right? Now, how to do this? I hope this concept is clear. Now, how to do it, right? How to do it? So what we can do? Just see here that this is the list: 1, 2, 3. Let's take just 3 elements or 4 elements, right? Now what we can do? This is the head. Let's call it current as well, just for simplicity, okay? And this is my empty list, right? You can give it any name, right? You can give it any name. So let's call it h1 or something like this, right? Now what I will do, to point this node to this particular, to point this particular instance to this, what things I need, right? What things I need? I need a pointer to this location, right? I need the current pointer of 1 to point to this. So this changes to this. Second thing. What is the third thing? The third thing I need is the new head should become, 2 should become the new head, right? 2 should become the new head. This is the third thing I need. What is the fourth thing I need? Fourth thing is, initially this list was h1, now it becomes like this. So that means now the new head or back, whatever you call it, let's call it h1. So now h1 becomes this, right? Initially it was null, it has become this. Why I need to update it? Because when I append 2 as well, so 2 will be pointing to 1, right? So I need a pointer to this node as well. What are the pointers? Let's recall once again. A pointer to this, a pointer to this node, a pointer to this node, right? And some way to make the next point to this. That's the main thing, right? And obviously you need to update this after you append it, you need to update the pointer to this list, right? These are the basic stuff that you need, right? Now let's see a pseudocode, and then we'll move to the code. I am spending some time in the explanation because the code snippet that we are going to discuss is useful in many problems related to linked list, right? So that's why. So let me start with let's call it a previous pointer. Let it point to null. So previous will be represented by this thing, right? The head I was calling. The current, as I told you, will be the head of my linked list, the original linked list, right? Now what I can do? So just think, to make, if I point the next pointer to this one, if I make this to point here, so I will lose the I will lose the reference to 2. So first thing, I need a temp pointer to point to 2, so that when 1 ka next is removed from 2 to this, I still have some pointers to 2, right? So that is the first thing that I need to do. So what I'll do, there will be some loop. Let's see what will be the condition of the loop afterwards. The first thing will be, I will have a temp, and what temp will do, this is my current, so temp will point to current ka next, so that I have a reference to 2, right? So it will be current dot next, right? This is the first thing that I will do. Now what is the second thing that I will do? The second thing is, I want this next to point here, right? And this is previous, so what is the second thing I'll do? I'll do current dot next equals to previous, right? List has been updated, right? Now what is the list? The list is there was, suppose, an empty node, and this was called previous, right? Now this is like this, right? This has become, this is temp, this is pointing here, right? This is something like this. Now what I need to do, I need to make this node as previous, right? So that whenever 2 points, so whenever I come into next iteration, 2 points to this node, right? Previous. So then what I'll do, simple stuff, I will make previous equals to current. Remember, this still is the current node, right? This is still pointed by a name current, right? Now what I need to do, I need to make this as the current node, right? So I do current equals to temp, right? So these are the 4 things that I do, and my loop will be reversed, right? Now what is the condition? Till which point will I do it? Till which point? So just see, current equals to temp. That means current is moving one step at a time. So there will be some point when current will point to null when I reach end of this list, right? So here what I'll add, while current is not equal to null, right? So while current is not equal to null, you do these stuffs. First, temp equals to current dot next. This is the first step because I don't want to lose this node, right? Otherwise, if I just remove this link initially, I lose a pointer to this node. So first I keep a pointer, a temp pointer. Then I make this to point here. Then I update this. Now previous will become equals to cur, and cur will be updated, right? These are the basic steps that I do. Simple stuff, a very traditional problem, right? Now let's move to the code part, right? So just see, I have done exactly what I have told into the explanation. On line number 13, I have checked for the boundary cases that if head equals to null or head.next equals to null. That means if my list is empty or my list has just one node, that means I cannot reverse it, right? So just return head. Otherwise, as explained, I have a previous node, I have a current node. Current is, so basically current and head point to the exactly same node. So while current is not equal to null, while I am not reaching to the end of the list, what I do, I take a temp pointer, current.next will point to temp so that I don't lose that reference to that node, right? Right now it is being referenced by current.next, right? Now current.next points to the previous node. That means the new list, a temporary list that I was forming, right? Now previous is updated to the current node and current is updated to the temp node, right? And then finally I return previous. Why I return previous? Because actually previous is pointing to the last node that I have appended in my temporary list, and basically that will be the head of the list, right? So that is why I have returned previous, right? So yeah, that's it for this video. Also, if you want to check, you can also check out the Leetcode contest playlist where I keep where I keep you posted with the latest solutions for all the Leetcode contests that happen, like bi-weekly, weekly, and all this stuff. Also, please do support this channel by subscribing it, and also if you like the content, do also like the video, and we'll be solving all these problems together. We'll try to be consistent, so daily we'll solve 1 or 2 problems. We'll stretch on weekends so that we cover these problems quickly, and also we'll be adding more and more problems. So yeah, if you find it useful, do support it by giving a thumbs up, do subscribe to the channel, and stay tuned for the next video, which is related to the reverse linked list part only, right? So yeah, okay, take care, bye bye.